Well, welcome back again, everybody. After a relatively long hiatus between some schedule changes of Wednesday schedules on our class day and then the spring break, I want to go over the remaining slides, at least the second half of the slides for the solar system. You know, you had already hopefully you had looked at the first part one of these slides. This is part two. We're going to talk today about the inner planets, starting with Mercury, which is the smallest planet. And there you see on the slide, I want to show you here. Here is the planet Mercury. Here's what the planet Mercury looks like from a satellite that we sent to Mercury to look at it. In fact, if you look at it, it looks very similar to our own moon. All right. And on the Mercury is the nearest planet to the sun. It takes about 88 days to go around the sun. Actually, it's pretty fast, and that's why it was called Mercury. Mercury was the messenger of the gods. That's why it got the name from the mythological character of Mercury. Okay, it's about 59 Earth days for one revolution of Mars around its axis. The way the Earth spins in 24 hours, this spins in 59 days. So it's relatively slow, the orbital period, the orbital rotation period of Mercury, but the orbit around the sun, as I told you, is 88 days. Mercury is the smallest planet. It mostly has an iron core, okay, and it's a dead planet, okay. Essentially, the temperatures on Mercury, because it's so close to the sun, range from 840 degrees Fahrenheit to around minus 275. That's almost an 1100 degree F difference. Okay. It turns out that the side that Mercury faces the sun is this 840 degrees, and in the shade, if you will, in the shade, it's minus 275. And that may sound unusual to you because when we talk about things in the shade, shades on the Earth is not as dramatic temperature difference as it is during the daytime. But the fact that Mercury has no atmosphere, it's very, very thin. Okay, the atmosphere is like an insulating blanket around the planet, and that retains most of the heat. So on the Earth, when we go into the nighttime and when we go into the shadow, then it doesn't get very cold because the atmosphere retains the heat and keeps us warm. Mercury doesn't have this property. Mercury does not have an atmosphere, okay, or it's very, very thin. So it can be very, very cold in the shade, even though it's so close to the sun, because there's nothing heating it on the shadow side of Mercury. But in the blazing sun, it gets to about 840 degrees Fahrenheit. Really, really hot on that side. And you can see Mercury from the photograph here. You can see Mercury is a planet that looks like the moon. It's been bombarded by meteors. That's why we have the craters in it. And in fact, let me just give you an idea of the size of Mercury compared to the sun. And just this past November, on November 11th of 2019, I have here, this is a photograph of a transit of Mercury. Mercury happened to be crossing the surface of the sun when viewed from the Earth. And if you can see this little dot, if you look real carefully, I'm circling it right here. That's the little dot of Mercury. Mercury's was crossing the surface of the sun across like about in this direction, right about the middle. And in fact, I had canceled class the last semester in November to actually take pictures of it that day because it fell on one of my class days. And here's one of the photographs that I took. And here's that the tiny surface of Mercury. So you can see how it looks to us from here on from our vantage point on the Earth. Uh, what's also interesting about Mercury is that the scientists discovered water ice in the shaded craters at the North Pole. At the North Pole, there are, right at the North Pole of Mercury, right around somewhere around back here, okay, there are some craters that are permanently in shadows. That is, no matter how Mercury rotates, it always stays in a shadow. And therefore, if it's always in the shadow, necessarily it's cold. And we've actually discovered water ice in that area on the planet Mercury. All right. We've also measured from satellites going to Mercury that Mercury is a shrinking planet. Okay, it's actually getting smaller because it's still cooling. It has an iron core, which you can see here. The iron core of the planet is still warm. Okay, and it's a liquid core. Okay, it's still hot inside and that's slowly cooling. And as it's cooling, Mercury is shrinking. It has this, the crust acts like a little surface and it's not being held up by anything because the planet is it's cooling. As it cools, what happens is that space that's taken up by the core shrinking makes the planet shrink. So Mercury is shrinking from that standpoint. And Mercury also, just to give you an idea, I told you it's the smallest planet. It's just about the size of our moon. You can see right here. Here's Mercury compared to our moon right over there. So these are some of the properties of Mercury, okay? It's one, remember that it's it's the closest planet to the sun. It moves around the sun very quickly, and it's extremely hot on Mercury in the sunlight, and it's extremely cold in the shadow because the lack of an atmosphere. All right, let's go to the next planet now out from the sun is Venus. And Venus is a hellish planet. If you had to describe hell, hell is Venus. Okay, Venus is called the Earth's twin because it's almost exactly the same size as the Earth. It's completely shrouded in clouds. That is, we really don't get a chance to see what the surface looks like. We have never seen it with a telescope from the Earth. In fact, the photograph that you see here was taken in ultraviolet light by one of the satellites. Some of the ultraviolet actually just showed some different reflections off the tops of clouds on Mercury. That's what you're seeing. You're seeing reflection from the tops of clouds. Mercury is the hottest of all the planets in the solar system. Okay, it reaches a temperature of about 880 degrees Fahrenheit. Okay, that's hot enough to melt lead. Okay, the atmosphere, actually, Mercury has a very dense atmosphere, whereas I told you, Venus has a very dense atmosphere. I told you Mercury doesn't have much of an atmosphere, but Venus is very dense, and the atmosphere traps in heat in what we call a runaway version of the greenhouse effect. Okay, and what happens is that sunlight is allowed to come into Mercury, I keep saying Mercury, sorry, comes into Venus, and the heat is reflected, is wants to be reflected by the planet, but the carbon dioxide in its atmosphere keeps the heat in. So it's just like a greenhouse. When you think of a greenhouse that has a glass roof and glass walls, the sunlight can come through the glass and the heat comes through the glass. But what happens is the glass, when the heat wants to escape from the greenhouse, it doesn't let it come out, and it keeps building up the heat. That's why greenhouses are so hot, and usually when they're watered in the greenhouses, they're humid too, but it's the heat that gets trapped in. What's happening here, the carbon dioxide atmosphere lets the heat in from the sun. However, it doesn't let it back out. And that's because it has a very high density of carbon dioxide in its atmosphere. And that's the thing that people are worried about on the Earth. If we get, because of burning fossil fuels, what we call fossil fuels are things like coal and oil and everything. As we burn those, some of the byproducts of using that on the Earth is carbon dioxide. And as carbon dioxide builds up in our atmosphere, it acts like a blanket that can cause the Earth to warm up. Hence, we use the term, sometimes we think the Earth is global warming. And we know that over the past 10 or 20 years, the Earth naturally has heated up over a significant amount of time. But only in the last 10 or 20 years has there been a dramatic increase. And that dramatic increase, scientists trace to the burning of fossil fuels and the releasing of carbon dioxide in the atmosphere. And that's trapping some of the heat in. And the Earth is slowly heating up. It's nowhere near what the temperatures are like on Venus. However, we think eventually, if it keeps building up in the atmosphere, this can happen to the Earth. But Venus is actually a place that's, as I told you, is hell. Okay, if you look here, here is a radar image of the planet Venus. When we send satellites to Venus, they have radar that can penetrate the clouds. At the radio frequencies that radar is, those can actually penetrate the clouds, and we can get a view of what it looks like on the surface. And what you can see is a surface here that's extremely hot with active volcanoes and lava flows on that planet. You can see the bright areas here of new lava flows. And so this is a place, in fact, I told you, the atmosphere, in fact, is so dense on Venus, it's at least 20 to 50 times more dense than the Earth. And therefore, the atmosphere actually creates a lot of pressure on the surface. And the surface pressure of Venus is extremely high. In fact, the first look we had of Venus was from Russians that sent satellites there back in the 70s and 80s. And the satellites really did not last very long, only maybe a few hours. The first few actually melted when they went through the temperatures on Venus. The others were crushed by the pressure on Venus, because it's like being at the bottom of the ocean. All that water is above you. The pressure is actually very high from all the dense atmosphere of Venus. So Venus orbits the sun in around 225 days, okay? It also rotates on its axis backwards. This is one of the only planets that rotates backwards. And it takes one day on Venus is 117 Earth days. So it takes 117 days for Venus to rotate on its axis, okay? Also, what I want to show you is just a few years ago in 2012, just to give you an idea of the size of Venus. Here is a transit of Venus, just the way we had a transit of Mercury. Not very often, Venus sometimes passes exactly between us and the sun and lines up so that we can actually try to photograph it. And here I actually photographed it from a local beach near my house, and you can see it was a very cloudy day that day, but I tried to shoot it through the clouds, and there's the planet Venus, that little bright dot, that little dark dot, excuse me, on the surface, going across the surface of the sun. You can see the clouds always here in the background. This was on June 4th of 2012. Okay, this was a transit that occurred just before sunset. It was around 7:45 in the evening. We know that in June the sun sets relatively late, so I had set up and try to take a picture. But you can see here, you can compare Venus, the size of Venus, to the size of the Earth when viewed, the size of Mercury when viewed from the Earth. Also, this little inset here is just a few days ago. In fact, I took a picture of Venus, and here it is right here. You can see it. Venus is in its almost in its quarter phase, if you will. Remember, we said that Venus had a complete set of phases, as Galileo had discovered, because it orbits between us and the sun. And right now, it's in the crescent phase. And this was back on April 6th, I believe. I took this picture of Venus. Venus, I told you, is very featureless. Because you only see the tops of the clouds, you can't see any features on Venus. This image here, I told you, was taken with a satellite with a very special filter that was allowed to photograph Venus with that special filter. But when you look at it from the Earth, you can see it looks very, very plain. You can't really see it. So there's not letting me features. I haven't really taken many pictures of Venus, and I thought I would just show you these. And this is the good one, in fact, because this doesn't happen very often, is this transit of Venus. So Venus is, as I told you, a version of hell. If you can think of any place that we imagine, like Dante's Inferno, we dreamed of hell. Venus is is that planet. And mostly it's because Venus has this dense atmosphere, and some of those volcanoes are also spewing out material, and that material is going up into the atmosphere. The carbon dioxide is building up, and also coming out from the planet from those volcanoes is sulfur. And sulfur dioxide is some of the gas. Sulfur dioxide smells like rotten eggs, if you've ever smelled it. And the sulfur dioxide actually combines with other materials in the atmosphere and forms sulfuric acid. Sulfuric acid is the same kind of battery acid we put in our car batteries. And so essentially it's almost like acid rain coming down sometimes on the planet Venus. So here's this place that's very high pressures, very high temperatures, volcanoes and lava flowing, very inhospitable place. That's why Venus is called the hellish planet. As we move outwards now, let's move out and take a look at the next planet. And we know that's our planet, the planet Earth. And we know that's unique in the solar system because there's liquid water on the surface. It has a fair amount of breathable oxygen. In fact, the atmosphere is mostly nitrogen, believe it or not. A lot of people think that our atmosphere is mostly oxygen. It's not. It's around 70% nitrogen and only 20% oxygen. And that 20% oxygen is what we've been accustomed to breathing. And that's how we breathe. I have a video here of
Earth.
Let's
the only
watch this.
planet known to maintain life. A product of scientific phenomena and sheer chance. This blue speck in space holds the past, present, and future of our very existence. Approximately 4.5 billion years ago, the Earth formed from particles left over from the creation of our Sun. Gravity drew these particles together to form pebbles, which then formed boulders and eventually the Earth. At its heart is a solid inner core covered by a liquid outer core. Above this sits the mantle made of flowing silicate rocks and a rocky crust. This rocky mass is the third planet from the Sun, orbiting the star from an average distance of about 93 million miles. It's close enough to the Sun to be warm, unlike the cold gas giants, but not so close that its surface is exposed to extreme heat and solar radiation, as is the case with Mercury. Earth's unique position in the solar system allows it to house phenomena yet to be found anywhere else in the universe, particularly liquid surface water and life. According to one theory, much of Earth's water is as old as its rocks, both of which having formed during the Earth's earliest days. Because of Earth's unique distance from the Sun, the planet is able to contain water in all of its forms, liquid, ice, and gas, rather than have them permanently frozen or evaporated into space. But Earth is the only known place in the universe with liquid water on the surface, thereby having unique cascading effects on the planet. It hydrates the land, helping create nutrient-rich soil. It collects and pools to form oceans and freshwater systems. And it cycles upward to add moisture to Earth's protective atmosphere. And where there is liquid water, there is life. About 3.8 billion years ago in Earth's oceans, primitive life existed in the form of microbial organisms. They, and the ensuing billions of years, gave rise to a range of more advanced life forms that thrived in Earth's seas, lands, and skies. As the only world known to harbor life, Earth's biodiversity is expansive in nature. An estimated 1.5 million species of plants, animals, bacteria, fungi, and others have been cataloged, with potentially millions, if not billions more, yet to be discovered. Home to life and fueled by water, Earth houses a unique global ecosystem, as curious and as grand as the astronomical events that made them possible.
So you can see from the video here that you know pretty much everything here, but also the Earth is unique in the solar system in that it's the only one that we know has life on the surface. Okay, we're still looking for life in other places on in the solar system, particularly on the other outer planets, perhaps on the moons of the outer planets, on some of the moons of Jupiter and some of the moons of Saturn. As we're going to learn later on, you'll see that there are some chances for some sort of life, whether it's we think it's some type of microbial life. Let's move on here. Let's look at next. I wanted to talk about the Earth has a protective magnetic field. And as you can see from the diagrams here, the sun is always ejecting particles. Solar radiation is being brought out into the solar system and bombards the Earth. And these particles that come out from the sun are charged particles. Okay, they have an electric charge on them. And as they flow out of the sun and completely surround all the planets in the solar system, because they're charged, the magnetic field of the Earth can actually divert some of these away. You can see right here, the blue represents the protective radiation belt that surrounds the Earth. And here you can see these are the particles streaming out, and they can actually, the Earth is protected from that amount of solar radiation because of its magnetic field. If the Earth had no magnetic field, then the radiation would completely bombard the Earth, would directly impact the Earth, and that radiation is damaging to life forms. It can cause cancers and kill off life forms very, very quickly. So we've been lucky in terms of the fact that our magnetic field has protected us and has kept us from being destroyed by the radiation coming from the sun. Sometimes, however, you can see towards the top here, you can see there's like a little hole, and some radiation can sometimes come down through the North Pole or come in through the South Pole. And when some of that radiation does that, it hits our atmosphere and creates these things we call auroras. And you can see here is an aurora we see mostly in the northern hemisphere and in the southern hemisphere. Auroras occur when the charged particles from the sun hit our atmosphere and cause some of the atoms in our atmosphere to glow. When those charged particles hit the oxygen in our atmosphere, some of them glow green, the way you can see here, and sometimes some auroras are green. You can see here in the photograph down here, you can see where we get a circular aurora typically occurs around the poles, both the North and the South Pole, depending upon the amount of radiation coming from the sun. Sometimes there could be a fairly large storm, and then what happens is this smaller ring of auroras can actually move down the planet and become a ring right around in a lower and lower latitudes. So sometimes if there's a really severe storm, perhaps even as low as New York or even down to Florida, we may be able to witness auroras. That doesn't occur very often. Mostly it occurs because the amount of radiation is relatively constant from the sun and really stays up in the northern hemisphere as these charged particles come in to both the northern and southern climate. You can see there's not a lot of people that live in Antarctica. We don't usually hear of a lot of auroras down there. In fact, the aurora in the northern hemisphere is called the aurora borealis, meaning northern aurora, and the auroras in the southern hemisphere are called the aurora australis, like Australia. But since a lot of people don't live in the southern hemisphere, don't live around the South Pole in Antarctica, they're not as popular, if you will, as we see photographs mostly coming from the North Pole. So remember, a magnetic field is very important to life on the Earth because the magnetic field deflects the radiation from the sun, keeping us from being bombarded with this radiation that would kill us very, very quickly. In fact, we know when the astronauts traveled to the moon does not have a protective atmosphere. And the astronauts were constantly bombarded by the radiation. Radiation also occurs on Mercury, on the planet Mercury. It's very close to the sun. Mercury has a very, very weak magnetic field. Okay, but the magnetic field of Mercury is not enough to protect it, and the surface of Mercury is constantly bathed in radiation that would kill us if we were to live on Mercury, or even if there were no magnetic field on the Earth, the radiation would kill us. Our magnetic field, just for your information, is generated typically by the molten iron core of the Earth. As this molten iron core rotates, as the Earth rotates, the iron core moves. That liquid is sloshing around in there. That moving liquid, metallic liquid, causes this magnetic field. And usually planets that don't have a magnetic field have his core is pretty much dead. They don't have any hot material in the core or any metals in the core that could be rotating to cause the magnetic field. We know from the video you just saw that the Earth does have a molten core of iron, and that results in our magnetic field. And God bless that magnetic field, because it's the one that's protecting us from all the solar radiation. So what I wanted you to understand is, one, about that magnetic field, and is also that the radiation from the sun is also responsible from some of the auroras we see. And mostly, I told you, the auroras occur by the north and south poles, because that's where some of that radiation can enter our atmosphere due to holes, if you will, in the magnetic field of the Earth. So magnetic fields are important. We're going to come back to them in just a moment. Let's go to the next slide. Next, we have the moon. Okay, the moon is around the Earth. It's not a planet. But I wanted you to understand about the moon. And here's a photograph I just took of the moon here just a few days ago on April 6th. I took a picture of the gibbous moon. That's you can see it right there. That's what our moon looks like, pretty common. And here's another interesting phenomenon. Back around 2 weeks ago, I took a picture of a crescent moon, and you can see here the bright crescent is overexposed right over here. It almost looks like a little smiley face, right? So I exposed it for so long that you can't see any surface where it's lit, but you actually can see some of the areas on the moon, the part of the moon that's in the shadow. And the way that gets lit up is from reflection of sunlight off the Earth, and that's reflected onto the moon, and we call this phenomenon earth shine. So sometimes when you're able to see some of the features in the shadowed area of the moon, when you can see those, usually you see them during the crescent phases, and that, I told you, that phenomenon is called earth shine. So here's a nice picture of earth shine just taken just a couple of weeks ago. The moon is actually one of the largest compared to the size of the planet. Our moon is about 1/6 the size and mass of the Earth. Okay, and as you know, as I told you, I think before, is that the moon was created. Our theory now is that early in the development of the solar system, probably, as we know, the solar system is 4.5 billion years old. But after the first maybe 300 or 400 million years, there were a lot of protoplanets forming, maybe hundreds of them, that were surrounding the sun. And these collided with one another and became the 8 planets that we know we have now. But we believe that there was a body that was about the size of the planet Mars, which Mars is about 1/5 the size of the Earth, that a protoplanet, which we called Theia, Thea, Theia, may have collided with the proto-Earth when the Earth was still in a molten phase, and actually broke off some material and ejected it out from the Earth. And this little protoplanet Theia was completely absorbed into the Earth. And some of the material from the Earth went out into space and actually started to circle the Earth. And the Earth actually had a ring, if you will, of this molten material that was out in space and starting to cool. And as this ring was going around the Earth, of the proto-Earth, remember I told you only about 300 million years after the Earth were formed, it slowly coalesced into possibly two bodies. We may have had two moons at that time, and those two bodies collided together and formed that one single moon. So we think that most of the material on the moon came from the Earth. And when we sent astronauts to the moon in the late 60s and early 70s, and they brought back moon rocks, guess what we found is that the rocks have the same constituents as the Earth. So the theory that the moon was created from a collision of a body with the proto-Earth is probably a good one. And as we know, because the moon is 1/6 the mass of the Earth, it has 1/6 of the gravity. All right, here if I have a little diagram here showing you that on the Earth, okay, you can dunk maybe 10 feet, right? You can jump up maybe 10 feet. I can't, maybe you can jump up 10 feet and dunk a basket. But on the moon, because of the lower gravity, we could go up to almost 60 foot. 60 feet if we had a dunk because of the lower gravity. And as I told you here on the moon, you also weigh 1/6 of what you weigh on the Earth because your weight is just given by how much the gravity pulls on you. So if I were to weigh, let's say, 240 pounds here on the Earth, if I were to go to the moon, I would only weigh 40 pounds, 1/6 of my weight because of that lower gravity. Okay, and here is a little diagram here showing you the size of the Earth relative to the size of the moon. Okay, it's only around 2,100 miles in diameter. All right, it's relatively small. Relatively small. However, it's the largest moon to Earth ratio. The ratio of the size of the Earth to the size of the moon is one of the largest in the solar system. So there's no other moon that's perhaps a percentage. It's not the percentage of the size of the moon compared to the Earth is the largest in the solar system. So that's just a little about our moon. Okay, formed from the Earth, we still think the moon has a core here that's still cooling in the center. We have the astronauts when they visited the moon, as you can see here in the late 60s and early 70s. They left seismometers or instruments that can actually measure moonquakes, if you will, just like earthquakes, and they're still active. The moon is still active. We can periodically see these moonquakes. The surface, also here you can see the surface of the moon. We know that the moon, the one side always faces us. Okay, it's called tidal locking. We said the moon, the time it takes the moon to orbit the Earth is the same time it takes to turn on its axis. So the same side always faces us. And these dark areas, we think, are areas of what we call the seas of the moon. The mare in Latin means water. We think it looked like water. It's not water, but what happens is from volcanoes that erupted, they had filled the landscape and actually smoothed that area. So they look like very, very large plains. So these are the mare, or the seas in Latin, of the moon. And you can see here the lunar highlands, the areas of mountainous area. You can see there's a very large crater here. That crater, I believe, is called Copernicus, named after Copernicus, that one crater. And you can see the rays coming out from that crater. Okay, as the impact of the meteor that hit the moon, probably early in its development, sprayed out a bunch of material, forming the lunar highlands, and here the lunar mare, or the lunar seas, the little flat areas of volcanic plains that are relatively flat. Here is an area, in fact, here, if you can see here, on the moon. This is about the Apollo 11, the first mission that went to the moon, went somewhere over here. And if I look at it on my photograph here, that's probably right around that area right there. This is the area on the moon in which the first astronauts landed. They wanted to obviously travel to an area that's relatively flat, so they travel to one of the mare here, we know is flat and not anywhere near the lunar highlands because of the difficulty in trying to uh, land something on the surface of the moon here. It's rather easier to land on a flat area than it would be to possibly go into a mountainous area. So that's some fun facts about the moon. Let's continue on now, and let's look at the next planet. Next planet is Mars. This is the last of what we call the terrestrial planets. Okay, and at first here you can see this is a photograph taken by one of the satellites that went to Mars, and we can see Mars was named after the god of war because the god of war was Ares. Okay, the Roman god Ares. Mars is the Ares, I believe, was the Greek name, I believe, and Mars is the Roman name for Mars, god of war, because it was red. It was blood red, so they thought that perhaps somehow that indicated something about conditions, and that's why it was named after the god of war. The reason Mars is red is because mostly the soil on Mars contains iron-rich material, okay? And the planet Mars has a very thin atmosphere. It does have an atmosphere. It's mostly carbon dioxide, okay? It's 95% carbon dioxide, a small amount of nitrogen, and it's only 0.1% of oxygen. We know we could not breathe on Mars. We know that the Earth, as I told you, has about 20% oxygen in the atmosphere, and that's what we're used to breathing. The atmosphere on Mars is extremely thin and only 0.1% of oxygen. So we could not breathe on the planet Mars, but that oxygen can combine with the iron in the soil, and what happens is when iron and oxygen mix, you get something called iron oxide. Everybody knows, or I hopefully knows, that iron oxide is rust. So Mars is essentially the rusty planet. That's why it's red, because the iron combines with a small amount of oxygen that's in the atmosphere to cause the red color. And as I told you, Mars is the fourth planet from the sun. Okay, it can get as hot as 70 degrees F, just comfortable, if you will, at the equator at certain times. But at the poles, it actually gets down to minus 195 degrees F. All right, so that's at the hottest and the coldest it possibly gets on Mars. The average temperature, however, on Mars is around 80 degrees below zero. Okay, so Mars is a relatively cold planet. Mars has also, as far as we know, and as far as measurements have made no magnetic field. That is, usually that means that the core of the planet has cooled, all right, and there's no metals in the core that are moving. And as a result of the magnetic field, of having no magnetic field on Mars, radiation from the sun bombards the surface. And we believe that early on in the development of Mars as a planet, excuse me, that Mars may have had water on the surface, okay, when it was still forming, when it was still warm, okay, when the inside of the planet was still warm, it may have had a magnetic field that prevented it from radiation from hitting Mars the way it does on Earth right now. However, because Mars is a lot smaller, Mars cooled more quickly, and as soon as it cooled, the magnetic field dissipated, and what happened is solar radiations kept hitting the surface and bombarded and blasted away whatever water remained on Mars has now been put up into the atmosphere and lost out into space. However, we believe there still may be water under the surface of Mars, all right, and some of the spacecraft that have been sent to Mars have actually found evidence of water under the surface. And in fact, if you look here in the photograph down here, here is a photograph taken from a satellite showing an area on Mars that may have had water flowing many millions of years ago or billions of years ago. We can see here sometimes what happens when in the summertime, when Mars warms up, in the summertime, some of that water may actually flow either underground or maybe a little on the surface. We haven't seen any, but sometimes we can see seasonal evidence of these little rivers, if you will, that have existed on Mars. And that's why we believe that at one time it may have had water. But now we certainly know it can sustain water because it has no magnetic field to protect it. So the amount of radiation falling on it has completely blasted it off. You can see here Mars is about a fifth of the size of the Earth. You can see here a comparison of Earth and Mars. Mars also has the highest mountain in the solar system. Okay, that mountain is called Olympus Mons. It's 17 miles high. Here is a photograph taken of Olympus Mons on the planet Mars. Mars also has one of the lowest points on its surface here, and that's an area that's now called the Valles Marineris. Okay, it was named after the Mariner probe that went to Mars in the 70s and discovered this scar, if you will, that's across the surface of Mars. It's almost like the Grand Canyon on the Earth, but you can see it's much larger. If you look at here, here is a map of the United States superimposed on a map of Mars, and you can see how large this canyon is on the planet Mars. It's one of the largest in the solar system, and it's about 6 miles deep and 2,500 miles long, almost the size of the United States. So those are the two features on Mars which are very prominent and make it unique in the solar system. So one, that it's red. Okay, we know that it has no magnetic field, so that its atmosphere has been blown away by the radiation from the sun, and all the water on the surface has also been blasted away from the radiation. And this could be the ultimate fate of the Earth. Should anything happen to the Earth's atmosphere, we know that this is what happened to Mars. However, we do think that Mars could be a suitable place for setting up an Earth colony. And obviously, it'd be very difficult for us to live on the surface of the planet Mars because of the radiation bombarding the surface. However, we think that we could live if we were to live in caves on the planet Mars. There are caves, a lot of holes that are formed by volcanic activity that form caves there, and we think the safest place to live is under the surface of Mars, where we would be protected from the radiation. We could travel once in a while outside to do some adventuring, if you will, or some exploring, but would have to live. If we lived on Mars, we'd have to live under the surface because of that radiation bombarding the planet. So that's little facts about the first 4 planets. We've heard a little about Mercury, about Venus, about the Earth and Moon, and now Mars. Let's move on now to talk about interplanetary matter. And when I talk about interplanetary matter, I talk about matter that's in between the planets. Okay? Here's a diagram of the inner solar system on the right-hand side. You can see here, I don't show the orbits of Mercury and Venus. They're close to the sun here, but here is the orbit of the Earth. Here is the orbit of Mars. And here you can see is this fuzzy belt of material called the asteroid belt. Okay, and in the asteroid belt consists of thousands and perhaps even millions of rocky bodies, rocky and metallic bodies. These are the asteroids, okay? They're not frozen material, but they're pieces of rocks and combinations of rocks and metals that probably never formed a planet. And the reason we say it wasn't a planet that broke up, but that never formed, because we think that because of the proximity of Jupiter to this and the large gravitational influence of Jupiter, Jupiter probably never as soon as a couple of pieces stuck together, Jupiter would go by and pull them back apart again. So this probably never formed a planet. There may have been another planet that perhaps would have formed, perhaps if Jupiter were not in this proximity. But this is what we call the asteroid belt. You can also see, sorry, excuse me. You can also see that in the area around Mars, there's these two little clouds of asteroids we call the Trojan asteroids. And these are gravitationally bound to Jupiter. That is, if you look at the Jupiter-Sun system, any two-body system like this has a point where the gravitational influence of the Sun and the gravitational influence of Jupiter will cancel out. And that's essentially a hole in gravity, if you will, right here. Any object that is right here will feel an equal pull from the Sun and an equal pull from Jupiter and will not be attracted anywhere. So it's completely captive here. And so there's a balance of gravity in this area and a balance of gravity in this area. And we call these the Trojan asteroids because essentially they were hidden from our view, just the way that during the Trojan War in Homer's tale of the Iliad and the Odyssey, when the Greek soldiers were invading Troy, they hid inside a wooden horse, what we call the Trojan horse, and that's how they got the names, the Trojan asteroid. It's funny, my professor when I was a professor my professor in college actually did work on that and discovered a lot of the Trojan asteroids. So those are also asteroids that are captive because there's no gravity pulling them. They follow Jupiter, and as Jupiter orbits around the Sun, these Trojan asteroids move with it. So we have this belt of material then surrounding the Earth we call the asteroid belt. And you can see sometimes if there are collision, asteroids can bounce against one another and bang against one another and all of a sudden can be ejected from the asteroid belt. And if they are, sometimes the Sun's gravity will pull them in and force them to go into an orbit around the Sun, a different orbit around the Sun, and actually cross the orbit of the Earth. And hence we call these type of asteroids Earth-crossing asteroids. And there are thousands we've discovered of Earth-crossing asteroids. Okay, here's an impression here, an artist's impression of what we think it looks like in the asteroid belt. Okay, there's a lot of material, different sizes, and I told you the material is either made of rock, made of metals, or made of combinations of rocks and metals. And sometimes these due to gravity from Jupiter or the gravitational pull of Mars or the Earth, sometimes it can launch one of these objects to come out of the asteroid belt. Of course, also particles can come out due to collisions. And some of those asteroids may be put on orbits that can orbit the Sun and cross the orbit of the inner planets, cross the orbit of the Earth the way you see here. Now the question is, well, what happens if the Earth is in the way with one of these asteroids coming in? And that's a real possibility. Okay, we know that in the past the Earth has been struck by asteroids. Okay, over its 4.5 billion year history. I'm going to show you evidence of that also. But there's also a danger of large asteroids hitting the Earth. Small ones hit the Earth almost every day. Very small ones. We're going to talk a lot more about asteroids in just a moment. Let's look at the next one. What does an Earth-crossing asteroid look like if we try to photograph it from Earth? And you can see here a star field, and in that star field you'll see looks like a line going across. And that line is actually the orbit of an asteroid. the asteroids don't move the way the fixed stars do. As the Earth rotates, the stars stay in the same position, okay, but rotate as seen from the Earth. But asteroids are not in the same or in different kind of orbits, and they move relative to the stars. Hence, they leave a streak. And this is probably the only way we can see asteroids. Asteroids are typically very small. The largest asteroid is only a few hundred miles in diameter, and they can range anywhere from a few hundred miles only to a few feet or even smaller in diameter. And we really can't see them from Earth. We can't, because they're so small, we can't detect them. Okay? However, we have sent satellites to asteroids to actually photograph them. And as I told you before, these are photographs that we could not do from Earth because asteroids are so small. But we've sent satellites here, and you can see here, these asteroids look like here. This looks like a peanut or something, right? It has a weird shape. This one looks like a sweet potato, actually a little color. This is the asteroid we call Gaspra. That's the name it's called. It's probably some type of name from mythology. And you can see here, this is a scale of about 10 kilometers, which is around 6 miles. Okay, and you can see here, this is possibly 40 to 50 kilometers, or about 30 miles in diameter. Okay, here's another asteroid here. Okay, this is the asteroid Ida. And in fact, if you look real closely, you can see an object right here. Okay, this asteroid actually has a little moon that travels, that's orbiting Ida, and we call that moon, it's called Dactyl. Dactyl is the moon of that satellite. Here's another one here. I always think this one looks like a meatball to me. Okay, this is the asteroid Matilda. Okay, how they got their names, I told you, I'm not sure how they got their names. This is around, you can see maybe about 50 to 60 kilometers long, okay, around 35 to 45 miles in size. You can see also the surfaces of the asteroids have these craters on them from impacts from smaller asteroids. These can also be broken off from these are pieces possibly broken off from larger asteroids. But this is when you move close up, this is what asteroids look like. Okay, and what you're looking at is a combination of rocks and metals, okay, all forming these bodies that are between the orbits of Mars and Jupiter in the asteroid belt. Let's look at here. The largest of the asteroids is actually a dwarf planet. Okay, and here is the dwarf planet Ceres. Ceres is actually the largest object in the asteroid belt. Okay, it contains 25% of the mass of the asteroid belt is contained in the planet Ceres. It's just under 600 miles in diameter. And as you can see, we call it a dwarf planet because just like Pluto, it's pulled itself, it orbits the sun. That's one of the criteria to be a dwarf planet. It orbits the sun. It has a round shape, but it's not. It hasn't cleared the neighborhood of its orbit. It's in a population of other asteroids that are surrounding that. However, it's one of the largest of all of them. It's called Ceres. In fact, you'll see here there's a little bright spot that's actually not a problem with the picture. This is a picture from a satellite taken, that's the Dawn spacecraft that was sent to Ceres, and in fact it's still in orbit around Ceres at this time, and it's that's what's called a cryovolcano. There's some sort of small amount of heat still inside Ceres, and that heat is migrating to the surface, melting some of the ices that could be around there. There could be some ices frozen in here, and some of these ices melt and come through cracks in the surface and are called cryovolcanoes. Okay, and that's what we think is happening here on Ceres. There's a lot more you can read about Ceres. I'm not going to go into it now. It's not as important to us now as continuing on. So Ceres is the largest of all the asteroids, and the second largest is the asteroid Vesta. Okay, here's the asteroid Vesta. It's only about 530 kilometers in size compared to the almost 1,000 kilometers in size that Ceres is. It's about half the size. It's about 329 miles in diameter. But notice the surfaces are all pockmarked, okay, from impacts of asteroids, other asteroids, hitting the surface and possibly breaking it apart. This could be a fragment of a larger body, okay, or or a fragment that was formed from a combination of bodies. So the important thing to remember is one is that this Ceres is the largest of all the asteroids, and it's 25% of the mass of the asteroid belt is in this planet. So Ceres is a planet, a dwarf planet in our solar system, and we know that Pluto is also a dwarf planet. We know this one, Pluto, is an ice ball. This is not an ice ball. This is mostly made out of rocks and metals, the Ceres. Go to the next slide. And I want to talk about something now. We know that the dinosaurs lived around 65 million years ago on the surface of the Earth. And we know that from evidence that we have found in the layers of material that we see on the Earth, that the dinosaurs went extinct very, very quickly. We know that there was a period in time, if we dig down to a layer that's about 65 million years old, we don't see any dinosaurs above that layer, and we see all the dinosaur bones below that layer. All right. And we think that there was a mass extinction event on the Earth. And scientists believe they have a lot of strong evidence to show that 65 million years ago, an asteroid about the size of Manhattan, about 6 miles in diameter, hit the Earth. And when that asteroid hit the Earth, it caused a global catastrophe. Okay. It actually set the whole Earth on fire, threw so much material up into the atmosphere that as that material rained back in, it was on fire, caused the whole Earth to be on fire. All the trees and all the vegetation everywhere on the Earth was caught fire from an impact of this asteroid collision. We know it caused tidal waves in the area because we know it hit in the area of an ocean. We're going to talk about where the evidence is if we think that this asteroid struck. But we believe the extinction of the dinosaurs was caused in a very, very short time, in a matter of days, that all the dinosaurs were killed by the impact of a very large asteroid, okay, by the destruction this caused. And we know that what could have happened is when the asteroid, and only 6 miles in diameter, not a very big one, when it hit the Earth, so much material was thrown up, as I told you, it came back to Earth, causing fires everywhere, blackened the atmosphere, prevented sunlight from hitting the Earth. All the plants died, and 70% of all life was extinguished from this type of catastrophe. This type of catastrophe does not occur very often. Okay, we think that a global catastrophe on that case, that's what this little thing is, a global catastrophe happens every about 1 million years. This is the strength of, let's say, this is the power of the impact. This is in megatons, in million tons of TNT. How many million tons of dynamite? From 1/100th of a ton to 100 million tons of dynamite. Here you can see this is the strength of the explosion, and this is how often we think they occur. We think that monthly or every year we have small asteroids that hit the Earth and really don't cause much damage at all. In fact, a lot of the asteroids may burn up in the atmosphere as they come through. They maybe not make it down because they're so loosely packed together, just the heating that they exhibit when they go through the atmosphere, because we know the Earth is surrounded by its atmosphere. And as this asteroid comes traveling through that, it's like a bullet going through the atmospheric molecules rub against the asteroid, causing an extreme heat. Just think about if you rub your hands together very, very quickly, you actually can warm your hands up, right? You build up heat. Well, as these very, very fast asteroids come in and hit the Earth, they create a tremendous amount of heat, and that heat may actually break up the asteroid before it hits the surface. But if it's a fairly large one, or it's a fairly dense one, let's say it's not made out of a lot of rock, but if it's made out of metal, it may survive. And in this case, we think that an asteroid only about 6 miles in diameter hit the Earth. Doesn't happen very often, and wiped out all the dinosaurs. What evidence do we have of that? Well, we know that there's an area in the Yucatan Peninsula, and you can see here's a map of the lower part of the United States. Okay, the Yucatan Peninsula is actually right over here, okay, down in Central America, if you will, right in the area of, there's an area in Central America called Chicxulub. There's a very small town called Chicxulub, and when gas companies were drilling to find natural gas, they found here, they were in the ocean, they actually found evidence of a crater under the water. It looked like there was an area, and this is a radar map showing the density of the material in the ocean. And it looked like almost that there was a ring-shaped structure here, partly below the ocean and partly also on land right here, but hidden by the jungle. Here's the area, if you will. Here's the Gulf of Mexico, if you will. Here's Florida, and you can see the area of interest is right here. And what they found was a crater under the surface. Okay, and just recently, just about a year or two ago, in samples that they took from this area, they actually went out on a ship and actually drilled down put a drill down in the water, pulled out core samples of that, and found that a sample that was about as deep, went down to as about as old as 65 million years. There was something unusual about it. And here is what that area looked like. This crater that we found underwater, I told you, was more than 110 miles in diameter. It's right near the town of Chicxulub in Mexico. And what we found in these core samples, and what we found in anywhere we dig on the Earth, if we dig down to we find a certain layer, and this is a cross-section of material dug around the Earth. We see this little layer right here. You can see it's black, and it's a different color than above and below here. All the bones of dinosaurs were found on a layer below this layer right here. This layer, if you analyze that material, it's very rich in an element called iridium. And that's very unusual because iridium is not very prevalent on the Earth. There's not a lot of iridium. Why was this layer of material, very thin layer, so rich in iridium? We know that asteroids are very rich in the element iridium. Not only that, but the color of this layer came from ash. This was a layer of ash, of material that was essentially on fire, because I told you the whole world caught fire. And this ash then deposited on the surface and then subsequently was buried by millions of years later on. So this little layer here was this layer of ash. It's found anywhere around the world. Anywhere you dig. If you dig down enough, you'll find this layer right here of material that's ash and iridium, and that's from that global catastrophe. And this is why we say that we believe that the dinosaurs were killed by the impact of a large asteroid on the Earth, because all the bones of dinosaurs were only found in layers below this one. That is 65 million years or under. None 65 million years or higher, the ones here. So this layer is anywhere you dig on the earth, we find this. So we know that the whole world was on fire. And that was indeed a global catastrophe, the impact of this 6-mile diameter asteroid that hit the Earth. Here's a little cartoon I saw in the paper just recently, and it's aliens visiting the Earth and says, "Hey, what do you guys do with all the dinosaurs?" Like they had been here before. But I thought it was something cute for us to look at. So let's look at here. I'm going to give you your next writing assignment, okay? Your next writing assignment is going to be due in a week, okay? I'll put out the date. I think I'll try to do it by next, let's see, what today is, the 13th, 22nd, either the 21st or 22nd, the next Thursday. I think I'll give you a little over a week and a half. I'd like you to watch a video that's on YouTube. And the link is right down here, okay? Don't click on this link again, please. Cut and copy and paste it into your web browsers. And it's about a 45-minute video, Nova video. It's called Asteroid, Doomsday or Payday. And it discusses about the impact of asteroids with the Earth, what we can do if an asteroid hits the Earth, and possibly what if there's a reason that we should travel to an asteroid, perhaps to try to mine them, because what we're going to see is asteroids are very rich in elements like gold and palladium and things. And these are metals that we know are very rare on the Earth, and we think that asteroids are very rich in them, and who knows, we could maybe even make a lot of money by trying to capture an asteroid and mine it for some of those materials. But most of this video talks about what we can do if we see an asteroid approaching us, okay? So I'd like you to watch this video, and you'll have about a week and a half to do the paper. This time it's a 500-word paper, okay? That's still a little more than about a page and a half, okay? The grading criteria, okay, are 50% of your grade will be for grammar and English. So I encourage you to please try to do the best you can and try to improve your grammar and English when you write complete sentences. Don't write run-on sentences. And 50% of your grade will also be for technical accuracy. How well do you describe what's happened in this video? So this is your final writing assignment, okay? The first one, you'll be getting your grades very quickly, okay? And this is the second and final one. Watch the video, this PBS video on YouTube, and write a paper, and I'm going to ask you to submit it to me via email. Just send me your paper via email. Please type it double-spaced to make it easier to read, please. And as I said, the criteria will be grammar and English usage and technical accuracy. So as we're learning about asteroids, I thought it's a very good video. In fact, a lot of people have seen it and said, wow, I didn't realize how interesting this is going to be. So it talks about, as I told you, the impact of Earth-crossing asteroids hitting the Earth, what we can do, how some of the evidence that some of these have hit the Earth, and then possibly some payday, if you will, if we can somehow try to mine these to maybe for our own personal gain, if you will. So that's it for today's lecture. Okay, this is the part 2 of the solar system lecture. Part 3 will be released in just a couple of days, but I wish you all well. Okay, and hopefully we'll touch base in a couple of days where I'll show you the part 3 of this. Bye-bye.